Okay. So for test 3, we're looking at these sections here. Okay. What do we want to start with? What do you want to start with? And if you have an example you struggled with in the problem set, we could literally do those examples. If everybody turned in the problem set, then I can put that solution up later today, and you'll have it the whole weekend. You can study all the answers. Okay, Luke is going to send me an email, let me know that everybody turned in and he's checking that. Tomorrow, what do you want to start with?
One of the things that on the problem set was,
You want to actually tell us what the question is and the number and section?
yeah.
Helen, go ahead. Okay. 28 was the first one?
Yeah.
All right, let me just pull it up real quick so I can see. Good. 40 and 43? Sure. Okay, find the value of k, these ones? Yeah, all right. So, okay, yeah, I'll go over that one for sure. So this is section 3-3, number 40. We'll start with 40? Yeah? All right. It says, find the value of k so that the given line has a slope given as m. So the line given is 6x plus ky equals 10, and m is given as -2. So we're told what the slope is here in this problem, and we're asked to figure out the unknown coefficient. So for a problem like this, you can either solve for y and put in slope-intercept, which some of you like to do, which is fine, or you can use slope equals -a over b. Since slope is equal to -a over b, I write the following. Slope equals -a over b, which equals -6 over k, which equals really -2. Okay, right? This is what slope is equal to. So this is my equation right here. All right, the blue box. What was the other one? 43? 44. These were a little bit tougher, yeah. So let's look at 44. Is this okay for 40?
Wait, so I got k equals 10 minus 6x over y.
Again, k is a number, right? This is a number here, so there's no way you could have variables in it. So what did you do?
So like I solved for k, and I think I just did it wrong.
Yeah, so you solved the equation for k.
Yeah.
It didn't say that though. It said find the value that k should be so that this line has this slope. And because slope is -a over b, I could say that -6 over k is equal to the slope that we want, and then just switch these two positions, I'll get 3 for k. Okay? That's fine. I'm glad, guys, again, a simple mistake on the problem set is nothing for your grade. A mistake on the test, huge part of your grade, right? 44, and then we'll go to Morrow. So this is 44 on section 3-3, then we'll go next. Did you have a question? So problem sets are homeworks. So if a problem set is at a 20, it's like 4 homeworks, because homeworks are worth 5 each. So it's really not a lot. It's really just for you guys to review and practice. Number 44 in section 3-3 says the following. Was it 44 or 43? 44. Find the value of k so that the line through the given point or given points has a slope of m. Oh, this is a nice one. I like this one. So the first point is k, comma k plus 1. The second point is 3, 2. And we're told that the slope is 3. So I have to think about my definition of slope. How would I find slope? Rise over run.
Yeah.
Okay.
So I just did.
Can I write this? Do you remember that from class too?
Yeah.
Okay.
K plus 1 minus 3 over k minus 3.
Start over. K plus 1 is the first y value. Minus. So here's what I have to do, right? I have to take y1 or y2, it doesn't matter what you call it.
Yeah,
Minus the other one. Over x2 or x1, it doesn't matter as long as you're in the same order. Minus 3. Okay? And now this has to equal the slope of 3. We're told that the slope literally is 3. So that fraction equals 3. So set this fraction equal to 3, and go ahead and solve this. It's not hard. Just cross multiply or just move things around. The top becomes k plus 1 minus 2, which is k minus 1 over k minus 3 equals 3. Multiply the k minus 3 up. This becomes k minus 1 equals 3 times the quantity k minus 3. Distribute and solve. I'm leaving it for you to do the rest of this, okay? The hard part is remember what to do there. So again, you're literally solving what's in that box, what's written in that box. This is just distribute the 3 to both terms and rearrange and solve for k. More.
Is it okay if you did the opposite way, like you did 2 minus k plus 1?
What do you think, More? Why?
Because
If you switch the order of subtraction, what does it do to that number? Make it the
opposite.
But if you opposite the top and bottom, is that an effect on the fraction? No. So Maura's question is, could you have doing y2 minus y1 over x2 minus x1? Absolutely. As long as you are consistent. If you're going to start with this coordinate and subtract this one, you got to start with this coordinate and subtract this one. But if you start here and you do 2 minus this whole thing, then you got to divide that by 3 minus this whole thing. As long as you're consistent in the order in which you do the subtraction. That's what delta means. Delta means change. Delta means change. We want to make sure our change is consistent in the way we're subtracting.
I found when I was going through the notes, like this one, I found this equation that said y minus y1 equals
M times the quantity x minus x1.
And I use that
Yeah, and you just used y and y1 as the 2 points and solve for m. That's called point-slope form. And when we get to point-slope form, we're going to utilize that. And that comes from our definition of slope. Because this is really y2 minus y1, which is y minus y1. This is x2 minus x1, or x minus x1. Very good, that works. You looked ahead in 3-3 or 3-4?
It was actually 3-3.
3-3, so you could use that, yeah. We haven't gone over point slope, but you could definitely use that. That's where the point slope comes from the definition of slope. And we'll show that in 3-4 when we show the derivation of all those equations. Next question. Next question.
Was
Section.
okay, it was section 2-4, number 24.
2-4. Let's find it. All right. Section 2-4, number 24 says the following. Solve is the direction. And it says 6 plus, I'm on the previous one. 6 plus the number 5 times the quantity absolute value 2r minus 3 is all greater than or equal to 4. Agreed? That's the one? Okay. Approach. What do I do, neighbor? Go.
You could just combine, add 5 and 6.
Yeah, let's just add 5 and 6. Come on, man.
Wait, what?
Can't add 5 and 6. PEMDAS. What's the 5 doing? The 5 is multiplying that whole thing, isn't it? So, before I go on to steps then, let me write the following, because I feel like I'm going to get a couple answers that I'm not going to like right now. How would I solve this?
Subtract 6 and then divide by 5.
So, how do I solve my remember what I told you? The simple way to do these problems is to approach whatever's in the absolute value as if it's just x. So literally, this is the same exact thing. These are absolutely identical in my mind, except for the fact, obviously, that I have a greater than or equal to instead of an equal to. And instead of this quantity, I put x. But however you would solve what's in red, you need to solve what's in blue. Because the key to any absolute value equation is to isolate the absolute value. Isolate the absolute value. Isolate the absolute value. So get rid of 6 and then get rid of 5. So let's try that again. Neighbor, go.
So subtract 6.
Go ahead. What do you got? What does it leave you?
-2.
Good.
Then you multiply.
I need to get rid of that 5.
So divide by 5. Oh, okay, that makes sense.
Next.
Then add 3.
Okay, at this point, I've isolated the absolute value. Remember that was my first statement I made? What do I do when I isolate an absolute value after that? What does this mean? What does this physically mean? Like, what are we actually saying with the statement, Regina?
It's just saying that that side has to be greater than or equal to that side.
Yeah, we're saying that some quantity in here, some quantity's absolute value will be bigger than or equal to this other number. Now, we have to recognize that this quantity itself, because it's an absolute value, it could take on the positive or negative role. So what did we say to do at this point? What do we do with this inequality at this point? We talked about breaking it up. Isabella, what do we talk about when we say breaking it up?
So you have to split it, and then it becomes 2r minus 3 is greater than or equal to negative 2 over 5.
Okay.
2r minus 3 is less than or equal to positive 2 over 5.
And this was our next step. And as you practice this enough, which you should have by now, this should be second nature. If you can't do this tomorrow, you're going to be at a real loss. This is something that some of you on the quiz really struggled with. Some of you just solved this as if the absolute value weren't there. Like I said, oh, yeah, I'm going to add 3 and divide by 2, I'm done. But the absolute value is clearly making this different. This is not an inequality. This is an absolute value inequality. It is different. You cannot just solve this. You need to break it up into the two terms. If you forget if it's or and, that's okay. We can show how to check that at the end. But, anybody know, is this or or is this and? Is or or this and? What do you think?
Or.
Why do you think it's or?
So there's 2 greater than or equal to the absolute value has to be either greater than or less than.
Agree, disagree? Agree? Let's show, see if it's right. I solve these individually. What's the easiest way to solve these kinds of problems? Even though we divided by 5, what do we really kind of want to do now at this point? I know we already divided by 5, so it's annoying, but what should we do?
Multiply by 5.
Yeah, multiply through by 5. So inherently, or in reality, Alex, you could have technically at this point stopped and broken it into 2 parts. One greater than or equal to negative 2, one less than or equal to positive 2, and then you could have divided by the 5. But it confuses students because then they put the 5 out here. Take a look. If you left the 5, it's out here. This needs to be in parentheses, and then you would have divided by that 5, or just taken the 5 and distributed it in to make it this. The issue that we're going to see, the concern that we're going to have here really, is that people forget to put parentheses around here when they drop the absolute value. So if you didn't get rid of that 5, it's okay, but you got to remember that the 5 is here, and then when you drop the absolute value and go here, this needs to be parentheses around it. Maura, what's up?
Do you have to divide multiply by 5?
No, obviously you could solve with all fractions, it's fine. I just find it makes it easier for me to get rid of fractions. Add 15 to both things, and then divide. Add 15 to both things, and then divide. So in this case, we've got a situation where we're told that r is greater than or equal to 1.3, and r less than or equal to 1.7. Greater than or equal to 1.3, less than or equal to 1.7. Can we graph those on a number line? So here's greater than or equal to 1.3. Here's less than or equal to 1.7. So you may find yourself at this point in the test a little bit confused, or at this point in the problem, because Mauro mentioned earlier that it's an or statement, but that doesn't look like an or statement, right? It really doesn't look like an or statement here. So we have to consider first several things. If this were an and statement, hypothetically, if it were an and statements we look for what? What do we look for on the number line with an and statement? The overlap, which would be here, correct? Is everybody with me? If it were an or statement, what would the answer be? If this could be the answer, or this could be the answer, what is the actual answer if it's an or statement?
Anything less than 1.3 or greater than 1.7?
All real numbers? Remember, or means it could be this, or it could be that, and together, don't these cover everything? So either our answer is all real numbers, or the answer is from here to here. Which one is it? Which one is it? Hang it. Besides the fact that you're remembering more things at the beginning. What's the way to check? Come on, people, how do you figure it out? Plug in. You got 3 regions. You've got a region below 1.3. You can try 1.5 and then try the number 2. So everybody, please go back to the original right now. Go to the original. Go to the original. Test 0, test 1.5, and test 2 in the original statement from the very beginning of the problem. See which regions create a true or false statement. Again, go back to the original at the very top and test the point in each of these regions. First, test the point to the left of 1.3. 0 is the easiest. Then between 1.3 and 1.7, test 1.5. And then test 2 since it's right afterward. And please test them up here and see if this is true or false. Can somebody help me and tell me what's going on? When I test the 0, right? 0 should be the easy one to test. 6 plus 5 times the absolute value of negative 3. That's going to be 6 plus 5 times 3. 5 times 3 is 15. 15 plus 6 is 21. Is 21 greater than 4? Yes, it is. This is true. So when I test 0, I get a true statement from the original. Again, I'm testing 0 in the blue at the very top. Okay, you'll get 21 is greater than or equal to 4. True, it is. Next. Test the number to the right of 1.7. 2. If I put a 2 up there, 2 times 2 is 4. 4 minus 3 is going to give me 1. 5 times 1 is 5. 5 plus 6 is 11. Is 11 greater than or equal to 4? Sure it is. So this looks like it's true also. Make sure I'm right. I'm just doing this quick. And then 1.5. 2 times 1.5 is exactly 3 actually, isn't it? Right? When I test 1.5 up here, 2 times 1.5 is 3. 3 minus 3 is 0. 0 times 5 is 0. 6 plus 0 is 6. 6 is greater than or equal to 4. That's also true. So the easy way, whenever you're in doubt, to see what the answer region should be is to test those regions that have been created as a result of these, what we're going to call eventually critical points. Have I used that phrase yet? Critical points yet in here? We will get to that, I promise. But there's a phrase I'm going to use called critical points. These are critical, meaning they create some sort of a barrier that may or may not exist or affect my answer. Okay, so based on this result, we can clearly see that all these regions provide true answers, which means that this was an OR statement, and it could be this R is greater than 1.3, greater than or equal to 1.3, or, so it's an OR statement, R is less than or equal to 1.7. So there's my answer right there in solution set form, but I would probably write R is all real numbers. R is in the set of all real numbers, or you could literally write, not this one, sorry. You can literally write negative infinity to infinity if it's given in interval notation. You can just write all real numbers. It's fine. Yeah.
So it's greater than it's or it's less than it's. But like, is that based on once you change it, or is like the original?
The original. Okay. So if we go back up here and we look at the very original in blue, it was a greater than or equal to 4. So the trend that we picked up on is very specific though, Regina. So point this or write this down maybe. It's always going to be with the variable term on the left. Okay? And read from the variable term toward the constant part. So whenever it's written in this form, where the absolute value with the variable, you read that first and then go to the other side. So if I had written it the other way, Regina, say I'd switch this whole thing up, I would have read this on this side, and then this symbol would be flipped around, but you would still consider reading it that way. So always read it from the variable side first. So I see this as the variable side is greater than something else. That triggers OR statement. If I had written it backwards, such as this, okay, let's say that's my statement. This is the exact same thing as that, isn't it? Look at it, it's literally the same thing. This whole variable side is greater than or equal to 4. So this is also an OR statement. Even though it looks different than what's up there, it really is the same thing. Because you got to read it from variable side toward the constant side. Okay? Hey, what's the answer? Yeah, I got it.
Can you keep the 5 in the original?
Yeah, so if you kept the 5 instead, Sebastian, you just got to remember that when you, because you'd break it up at this point then, right? Right when you're here, right? That's when you'd break it up. So when you break this up into two pieces, you just got to remember to have 2r minus 3 with parentheses surrounded down here, and then the 5 would just be on the outside of both of those spots. Okay? What's the answer? Something like this. What's the answer? What's the opposite of that? Correct yourself. What's the opposite of the answer you just gave? No what? No answer, no solution, right? Why is there no solution? He started with lower numbers and realized, oh, I make the other one. Why is there no solution? Yeah. The absolute value of a number when we solve for x and r, when we plug it in, should equal a positive answer when we check it, right? So no matter what I get for r, if I check the answer, can it ever be negative 5? Because I'm taking the absolute value of whatever I get. So give me a r value, it doesn't matter. Call r 0, call it 10, call it 20. No matter what, even if r is negative 10 million, you're going to take the absolute value when you plug in your answer, and that's got to equal a positive number. So whenever you have absolute value equals a negative number, it will never give you an answer. There's no solution to this. Yes, Maura?
What if it's like greater than negative 5?
Greater than negative 5. So let's take a look and think. If I didn't know and I was taking the test and it was written like that, hypothetically, greater than or equal to or greater than, doesn't matter. I'll just say greater than for now. So let's say it just said greater than. If I wanted to try and solve this and I had a greater than statement and I'm not really sure, just go like this. Because now, here's the thing. If I go to solve this, I think part of it will be solvable and part of it won't. Because we have the two parts to the inequality there, right? So when I look at this, let's see. Absolute value. If anything, actually, the answer is all real numbers. Never mind. Go back to the beginning. The absolute value of anything is always going to be what kind of an answer? It's always going to be a positive number. And a positive number is always greater than negative 5. So that'll actually give you all real numbers as an answer without even doing the problem. The other way around wouldn't work though, right? Less than wouldn't work. If you had this instead, this will never work. The answer is no solution to this. Because the absolute value of whatever you get is positive, and a positive will never be less than a negative. So that can't work. So this is no solution, and that one at the top is all real numbers. Okay? Once we changed it to greater than, it was all real numbers. Yeah?
So there is another problem.
Go for it.
Is a graph of line 2x plus 1 equals 0. Would that just be across the x-axis?
Yeah, so if I have a line like this ever, and I don't have x and y, it's automatically what kind of a line? It's one of two cases.
A vertical,
Or,
horizontal.
it's one of those two. Whenever x or y are missing, it's got to be a vertical or horizontal line. And if I forget, I just think to myself, if I solve this, this is what I get. And you look and you think, that's just a solution, right? I subtract 1, divide by 2. It's like I'm solving an equation. But because it said graph a line, I think to myself, how can I have a line where x is always equal to negative 1/2? Give me an infinite amount of coordinates that always have x equal to negative 1/2. So I start and I say, well, this is negative 1. We'll call this negative 1/2. So negative 1/2 comma 1. That's a point right there. Negative 1/2 comma 2. Negative 1/2 comma 3. Negative 1/2 comma negative 2. Negative 1/2 comma negative 4. See what I'm saying? I'm making x equal to negative 1/2 for all of those coordinates. And eventually, if I put enough coordinates, an infinite amount of coordinates, I get a line. So this becomes a vertical line crossing the x-axis. If you want to, for those that are struggling with remembering, here's a quick memory tool. If it says x equals, that's also giving you the x-intercept. And if you have the x-intercept, the line must be vertical. If it says y equals, it's giving you the y-intercept also. And a y-intercept line must be horizontal. If you have the y-intercept, you can't be vertical unless it says x equals 0 or y equals 0. But what's x equals 0 really? What is x equals 0? This is x equals negative 1/2. What does x equals 0 look like, Maura?
If x is equal to 0, then it would just be across the y-axis.
It is the y-axis. It is. The line x equals 0 is the y-axis. That's why when you find the y-intercept, what do? To find the y-intercept, set
You make x 0.
x 0. Because the line x equals 0 literally is the y-axis. Think about it. This is x equals negative 1/2. This is x equals negative 1. This is x equals positive 1. X equals 0 is the y-axis. That's why you set x equal to 0 to find where it crosses the y-axis or the y-intercept. Now let's quickly do that because some of you made some fumbles this one in the quiz. Graph quickly by finding the intercepts only. Please, I know you can graph with slope intercept, and it's a very useful tool, and we're going to use on the next test, but I need to see that you can do this because you're going to use this a lot more in calculus. A lot more, with way more developed equations than this. So I want the x-intercept, so I set y equal to 0. When I do that, I get the following, which gives me an x-intercept of 10/3. That means I have a coordinate of 10/3, comma 0. That's what I want to see. Okay, this is literally what I want to see on your test. This is so easy, it's like 3 points, it's unreal. Okay, there's your x-intercept by setting y equal to 0. Honestly, guys, when people don't do this right, it just shows to me that you're not always listening when I ask you things. Because some of you still did y-intercept or slope intercept in the quiz. This is really so simple. Set x to 0 to get the y-intercept. It's just going to be negative 2. It doesn't make sense why you wouldn't practice this and learn how to do it. So I've got 2 intercepts. All I need are 2 points. As soon as I have 2 points, I can make a line. 10/3 on the x-axis will be around 3.33. So I should reasonably have numbers that make sense. So go by 1s. And on the y-axis, I'm going to go by 1s also. I will give you grid lines. You have to label everything. You'll have grid lines. So y equals negative 2 is down here. There's my 2 coordinates. And I just connect them with a line and you're done. You don't have to do any more. I should label appropriate axes though as well. What else? What other things are we struggling with? Let's go ahead.
It was number...
C. Oh, Jesus.
It was
In chapter 3 or in chapter 2?
I don't remember. I think
Was it
chapter
involving
3.
lines?
It was like the variables and you switch them. And... Hold on.
Look for it for a little while. It's all right.
Sorry.
It might be 3-1. I think it was 3-1 with the word problems that we had.
Oh, okay. Sorry. Wait, should I go?
Can she go first? Okay.
Okay. It was 2.5, number 28. I think I got it, but I'm not sure.
2-5, number 28. 2-5, number 28. Number 28 says the following. X plus C in absolute value is greater than C, correct?
Mm-hmm.
And 2-5, oh, this is good. We haven't done this yet. 2-5 is solving by what? How are you solving these in 2-5? Yeah, graphically, right? Graphically. So we need to know our technique. So our technique always begins by having subtraction. So let's rewrite this as subtraction, which means that must be a negative C. What is this called? There's a word for this. We called it something. We called this our... Come on, we need to know these terms. It helps the graph. It comes up with your answer. It's where the answer comes from.
Starting point.
Starting point, and this is your? Very good, deviation. So let's make a number line. Negative C is on the starting point. Yeah, I know, it's kind of weird, right? What's negative C? It's a number. I don't know what it is. I don't really care what it is. Here's the thing, though. If I deviate by C, I'm at negative C, and I deviate by C. What does it bring me to?
Negative C plus C.
Which is? 0. So the next point over here, you're going to deviate. Remember, deviate means add whatever the deviation is. So add C to negative C. That'll get you to 0. Subtract C from negative C. That'll bring you to negative 2C. Open circle, open circle. It's a greater than statement. A shade outward. A shade outward. Let me show that one more time real quick so those that had trouble with this. This is a tough one for sure. Great question. Great question for the test to know. So I start at some random location that I don't know where it is. I just call it negative c. And I think in my mind, I'm taking negative c and I'm adding c. These two things, when added together, yield 0, which is what brings me to that. Then I take negative c, subtracting another c brings me back to negative 2c, which is this endpoint. Because this is a greater than symbol, this is an or statement, and we shade opposite directions. What would my answer look like? What would my answer look like? It's an easy one. What's my answer? What do you got?
Your answer would be C.
X.
Oh.
X was the variable we
Right,
started.
right. X is less than negative 2c, and x is greater than 0.
Or.
Or.
Thank you. In solution set form, how about interval notation? Interval notation. Someone besides Moore for interval notation. What do you got?
It's like you do the parentheses, negative infinity, comma, negative 2c, parentheses, or 0, parentheses 0, and then you do infinity with another parentheses.
Very good. Why all the parentheses? Why no brackets anywhere? Yeah, open circle means parentheses showing it's not included. It's an open interval, not a closed interval. The parentheses over here are just indicating you can't really get to infinity, so it's never included in the answer. This means or. This is indicative of this region. This right here is for this region over here. Yeah.
So, say like your starting statement was already a minus. So, like say it was x minus 2.
2 is your starting point.
Just be 2.
Yep. Yep. Correct. So x minus c, the starting point would have been c. Sebastian.
3 to number 12.
3. This says the following. Number 12. Okay. It says find the slope of the line containing the points. If it has no slope, write vertical, right? Okay. So the points, though, here are just variables. That's what makes this one a little bit tricky. A, B, and the second variable negative b, comma, negative a. So when I want to find the slope for something here, I have to right away think about my definition. My definition of slope is the change in y over the change in x. The change in y will be this right here. I always subtract downward, by the way. It doesn't matter. Whichever way you do it, it doesn't matter. I take whichever point is written first and subtract the second point from it every time. But it doesn't matter as long as you're consistent. So I'll do the top minus the bottom, which is b minus negative a over a minus negative b. But when I have a negative, what does that just become, everybody? So b plus a over a plus b, what does that become? Just 1. Okay? Because those values are the same. A plus b and b plus a are the exact same thing, right? Commutative law of addition. So it equals 1. Hey, for the proof part, know your laws and stuff. You don't have to have them memorized. I told you I'll give you choices for that. But if you're studying them, study the ones that we did as examples. Okay, look at those. Even look at some of the ones from like chapter 1. Some of the stuff we did earlier. But I'll definitely give you one with like a statement reason column.
Yeah. So you'll give us multiple choice like.
For that, I'll give you options. Yeah, you'll have like a bank of possibilities, and you can choose from that bank. Some of them could be used more than once, some might not be used, but I'll put all the properties down, so you can literally figure out which property goes to which reason. So you don't have to memorize the exact name, but you have to know what they mean, right? Other questions, please keep asking if you have. What haven't we done yet? We haven't done a word problem. How about this? Can I dictate? Can you guys write? Here's the question for you. We're going to come minutes left, so let's make it quick. Ready? Here we go. Let's say that. Oh gosh. How do I say this? Okay. Let's say the following. For the play coming up this fall, it's an easy example, so I'm just using it. For the play coming up this fall, student tickets sell for $7 each. Student tickets sell for $7 each. And adult tickets sell for $8 each. I should make them actually better than that because that might not work. Let's make it 4 and 8. Let's make it 4 and 8 to make sure this works. Student tickets sell for 4 and adult tickets sell for 8. If the total revenue brought in is $224. If the total revenue brought in is $224, what are the possible combinations of student and adult tickets that could be sold? Student tickets are 4 each, adults are 8 each. You bring in $224. How many of each tickets could have been sold? So this is a question where obviously your domain is limited. What kind of answers can you not have for number of tickets? What can they not be?
Negative.
It can't be negative. What else?
Decimals.
And decimals. So we are looking at the whole number set, right? Whole numbers are from 0, counting upward, all the integers from 0 upward. So what are the possibilities? How many possibilities are you going to have?
Infinite.
Well, no, in this,
Not like
not infinite, but
all.
a whole lot probably, right? Because of the fact that you sold $224 worth of tickets. So this would take forever, but it's the setup. So let's write the setup together. Here's what the setup would be. All right, X equals number of, what did I write wrong already? You both have your hands up. Oh, okay. I'm like, oh my gosh, you both shut up. Yeah, good. Either first.
Is it okay if we do like S and A, or does it have to be X and Y?
Whatever you want to make it. Yes, good.
On the test, will we have our calculator?
Oh, that's a great question. It's not going to need a calculator for this test at all. Okay, I will not make any of the math difficult where you need to worry about decimals or anything like that. If you're dividing a number by 2, you better be able to do it. Like 7 over 2 is 3.5, you know. But you want to worry about like a lot of thirds, and eighths, and sevenths and stuff. So it will be a non-calculator test, the whole thing actually. There's no need for it whatsoever, like I said. I'll go back to having calculators on certain parts also. Okay?